Out here in Cannon Beach, local agencies tell me that although king tides are a beautiful natural wonder and they encourage folks to come out and see them, they're also issuing this warning: keep your distance.
No.
And this video, shot on Thursday, shows exactly why.
Christmas morning brought California tragedy. Now the wave of fear sweeps north. At 6:12 a.m., a tremor off the Oregon coastline was strong enough to rattle kitchen cabinets. Beneath the urgency looms a slow-moving terror. The Cascadia Subduction Zone has made itself felt again.
Christmas morning brought California tragedy. Now the wave of fear sweeps north. At 6:12 a.m., a tremor off the Oregon coastline was strong enough to rattle kitchen cabinets and set wind chimes trembling. Not long after, seismic sensors up and down the Pacific shore registered a burst of seismic activity, prompting concern, if not outright alarm. The situation escalated swiftly as authorities reviewed evacuation routes, tested sirens, and news outlets buzzed with live briefings. Beneath the urgency looms a slow-moving terror. The Cascadia Subduction Zone has made itself felt again. For decades, scientists warned about this hidden hazard, a tectonic boundary that slips in silence, storing centuries of power. Now, the ground is sending signals stronger than any routine drill, and offshore earthquake swarms have become messages. Catastrophe is no longer theoretical. Throughout Oregon, residents pace kitchens, phones in hand, awaiting the next update. Each small vibration prompts a new question. Each aftershock spikes heart rates. The threat stretches beyond property damage or sleepless nights. The fate of the Pacific Northwest may, it seems, be measured in years, but many wonder if the clock is ticking faster. What exactly has triggered this new wave of urgent alerts, and what hidden truths about Oregon's foundations are rising to the surface? What secrets are the sensors, the experts, and the very rocks themselves finally revealing? Chapter 1. The Cascadia Threat Unleashed. Imagine standing on an Oregon beach, toes buried in cool sand, waves snapping against basalt cliffs. A scene as timeless as the coast itself. Now, beneath your feet, something moves unseen. The Cascadia Subduction Zone, stretching from Northern California's Cape Mendocino to Vancouver Island, is more than a name in textbooks. It is a geological juggernaut, an offshore fault line that has stored rising tensions for centuries. What draws such intense scrutiny from scientists and emergency planners today? The answer is encoded in the region's rocks and the pressure gauges scattered from continental shelf to coastal foothills. For the first time in years, a cluster of moderate earthquakes pulsed along the offshore fault, including a magnitude 5.4, rattling nerves and forcing urgent assessment. These tremors do not simply dissipate energy, rather they draw attention to the state of stress accumulating offshore. Patterns mapped by digital seismographs reflect concentrations of seismicity that can't be ignored, although experts emphasize that earthquake swarms are not in themselves proof of an imminent large event. On shore, the drama is palpable. Lifelong residents, accustomed to talk of the big one, now debate whether to pack family heirlooms or finish breakfast as usual. Some watch ocean swells, wondering if deeper forces are stirring beneath. The mood across Oregon's shorelines, one of anxious anticipation, sets the tone for what many hope is a false alarm, but fear is the beginning of a long ordeal. Chapter 2. Elevated Alerts and the USGS. Before sunrise, state emergency offices received a jolt. The US Geological Survey elevated its assessment of seismic risk along parts of the Oregon coastline. While not an official red alert issued uniformly by the USGS, since such real-time red alerts are generally reserved for ongoing quake damage or tsunami impacts, the tone of warnings and the heightened state of preparedness have rarely been higher. What makes this escalation so historic and so alarming for Oregon? Unlike previous alerts, this escalation draws from an unusual clustering of moderate quakes, synchronized spikes in pressure sensors, and subtle anomalies in coastal GPS readings, enough to warrant close scrutiny and a readiness posture not seen in years. While the USGS has pointedly stated that recent activity is worth watching, it has also cautioned that the ongoing earthquake swarm offshore does not indicate that a catastrophic quake is imminent. Nevertheless, public agencies and emergency managers have stepped up preparations, driven by a convergence of worrisome but not yet definitive signs. In city halls and command centers, officials pore over maps and live data feeds. Evacuation orders are reviewed, emergency kits are checked, and local leaders voice reassurance while urging vigilance. Even when the probability of a major quake remains low, the possibility, scientifically acknowledged as a matter of when not if, brings a sharpened sense of purpose to the coastline. The atmosphere is electric, strung tight between the weight of scientific warnings and the unpredictability of nature. Chapter 3. Earthquake swarms, ominous, but not destiny. Every second the ground writes a story, says seismologist Dr. Marcus Ellery, studying data from offshore sensors. This week's earthquake swarm, short, sharp shocks at shallow depths, has drawn the attention of geoscientists nationwide. Although tremors under the Pacific are common, a tightly clustered sequence along known locked segments of the Cascadia Fault attracts extra caution. How does a sequence of minor quakes escalate from background noise to regional anxiety? The answer lies in the mechanics of stress transfer. Each earthquake can, in theory, bring a portion of the fault closer to failing. However, the vast majority of such swarms dissipate without triggering the region's feared megaquake. Experts caution that while swarms like this warrant study, most are not harbingers of catastrophe. Yet, the current sequence, marked by depth, frequency, and brief migration, reminds residents and scientists alike that this system is not fully understood. In coastal towns, news segments play out animations of faults slipping, colored lines crawling slowly across digital maps. Social media amplifies terms like swarm and foreshock, even when these labels are premature. For now, the pattern has put Oregonians on edge, but experts continue to stress, earthquake swarms do not necessarily equal imminent disaster. Chapter 4. The Cascadia Zone's deadly design. Oregon's landscape was shaped by upheaval, towering headlands, battered dunes, and the ceaseless roar of the Pacific, all bear witness to the subduction zone offshore. What makes this region uniquely hazardous is the geometry of the Cascadia Fault, a long, shallow interface between the Juan de Fuca and North American plates. What then makes Cascadia so dangerous? Unlike many fault systems, the Cascadia interface can remain locked for centuries, accumulating massive amounts of strain before abruptly releasing energy. This silence lulls residents into a sense of calm. Geological records, from buried forests to deposits of sudden sand layers, confirm a periodic cycle of devastation. The threat is not simply the size of the fault, but its ability to strike when least expected. Local geology classes visit Cannon Beach, where salmon-pink clays beneath the surface testify to past liquefaction. Folklore, of ground that moved like water, is now backed by evidence. Both the landscape and human stories bear the scars of ancient upheavals, serving as a reminder that the Cascadia Subduction Zone's power is still present and never far from the surface. Chapter 5. Sensor networks light up. Code red across every station, a technician murmurs as rows of seismic gear pulse with data. Overnight, digital instruments along the coast captured a surge of ground motion and pressure. GPS baselines shifted minutely, and deep oceans recorded anomalies consistent with tectonic strain. While no one reading signals disaster, the cluster has scientists' attention. Why are multiple sensor systems from land to sea recording anomalies all at once? Individually, each sensor can be calibrated to catch subtle movement or pressure. Taken together, their readings map the region's tectonic pulse. The rare simultaneous blips across instrument types suggest genuine ground deformation. While such fluctuations happen periodically and can be caused by natural tectonic loading, when combined with a seismic swarm, they justify heightened vigilance. Technicians monitor systems from Salem to Coos Bay, watching for patterns in color-coded arcs. In rural towns, volunteers ready warning sirens for those living outside cellular networks. It is the network of sensors that speaks clearest, a sophisticated bulwark against the ancient threat offshore. Chapter 6. Unraveling the Geological Clock. Dr. Lena Chang, a geologist, pores over paleoseismic maps and sediment cores that tell a story older than Oregon itself. The coast holds a memory encoded in mud and tree rings, evidence of prehistoric quakes and drowned forests. These are not just stories, but science. What does this memory reveal about the risk today? Roughly every 250 to 350 years, Cascadia ruptures in a massive earthquake of magnitude 8 or greater. The last event occurred in January 1700, confirmed through Japanese tsunami records and analysis of sudden die-offs in local forests. That means more than 320 years have passed since the last major rupture. This places the region within the statistical window, not a prediction, but a warning grounded in geological history. In coastal marshes, scientists find abrupt layers of sand and buried roots, telling tales of disaster and rebirth. The evidence under Oregonians' feet is a cautionary message. Large earthquakes have happened before and will come again. Chapter 7. The Aftershocks, Anxiety and Uncertainty. From Newport to Seaside, quiet anxiety permeates communities. Small aftershocks ripple beneath the earth, barely felt by some, but closely tracked by seismologists and engineers. Why are aftershocks, even weak ones, a source of unease? Aftershocks are normal responses as the crust finds a new equilibrium, each vibration a leftover from the main movement. Yet, a rapid succession of aftershocks close to a known fault can keep nerves frayed and communities alert. While experts reassure the public that aftershocks do not necessarily indicate a coming megaquake, they do remind everyone that the system remains restless. For coastal families, the reality is lived one moment at a time. Shoes by the bed, flashlights by the door, emergency plans rehearsed, but normal life struggled for. Digital mutual aid groups spring up, teachers reassure anxious students, and radio voices fill homes with advice. The aftershocks may be minor, but the sense of unpredictability is powerful. Chapter 8. The Science of Imminence. Dr. Robert Voss, earthquake physicist, pores over incoming data from coastal and offshore sensors. He reviews seismic waveforms and ground deformation, stacking new readings against years of quieter records. What threshold must be crossed before scientists label a risk imminent? No single signal, no one earthquake or sensor reading triggers such a declaration. Risk assessment is built on a convergence of findings, ground shift, clusters of quakes, and changes in the speed of seismic waves. Oregon's current uptick is concerning, but not yet definitive. Scientists reiterate, most earthquake swarms do not directly precede a megaquake. Still, awareness has sharpened. Emergency managers move from mere monitoring to active readiness, briefing responders and reminding communities of the need to prepare in advance. Chapter 9. Faults, fractures, and future risks. Oregon's jagged coastline hides a complex network of secondary faults, structural geology that extends from the coast to the Cascade volcanoes inland. How can this network amplify disaster during a major quake? Secondary faults sometimes move independently, but can also be activated by a massive subduction event. When multiple faults rupture, shaking can be more widespread and persistent, reaching areas once thought insulated from direct impact. Emergency simulations and insurance risk models now account for these secondary risks, revealing vulnerabilities in inland communities as well as on the coast. Recent drills simulate widespread infrastructure outages, highlighting the interconnectedness of Oregon's geology. Local geologists and emergency professionals now include even distant communities in their risk planning, because when the main fault moves, aftershocks and related fractures will almost certainly follow. Chapter 10. Tsunami, the silent avalanche. Beyond the shaking ground lies another deadly threat, the ocean. A great rupture offshore would heave the seafloor upward, sending a tsunami toward land at terrifying speed. How quickly could a tsunami strike Oregon? And why is this threat so notorious? For large parts of the coast, the warning interval would be less than 15 minutes between earthquake and tsunami arrival. The ocean floor's slope and the region's broad shelf cause water to pile up rapidly. Geological records and indigenous stories bear witness to tsunamis that inundated broad swaths of low-lying land centuries ago. Unlike most natural disasters, the time between warning and impact is counted not in hours, but minutes. Public safety efforts focus on education, evacuation maps, siren drills, and signage in every coastal town. While the science of forecasting has improved, nothing can change the speed at which the sea moves in the wake of a violent rupture. Tsunami shelters and inland safe zones are essential to survival. Chapter 11. Volcanic connection, the Cascades corridor. Seismic unrest doesn't end with earthquakes or tsunamis. The same tectonic forces that drive the subduction zone also nourish the Cascade volcanoes. Could today's tectonic events awaken Oregon's volcanic hazards? While there's no evidence of imminent eruptions, large earthquakes can, historically, trigger or accelerate volcanic processes by altering subsurface stress around magma chambers. Instrumentation, gas sensors, thermal cameras, and more does show minor fluctuations around the more active volcanoes, but no emergencies have been declared. The linkage between earthquakes and eruptions remains a field of active study and a source of regional concern. On cloudless days, the outlines of Mount Hood, Mount Jefferson, and the distant profiles of Mount St. Helens and Rainier remind Oregonians of that layered risk, even as vigilance is focused elsewhere. Chapter 12. Infrastructure at risk. As emergency managers review response plans, the map is filled with critical details. Bridges, highways, ports, and power substations, all running through land that may never have faced a maximum credible earthquake. How vulnerable is Oregon's infrastructure to a Cascadia rupture? Much of the system was built before modern seismic codes. Bridges and seawalls in particular, vulnerable to both shaking and liquefaction, are widely recognized as weak links. Even newer structures may be tested in ways engineers can't fully simulate. Road service crews, utilities, and public works agencies prepare, but acknowledge that isolation, blackouts, and road closures are likely across much of the affected region if a major quake strikes. Helicopters stand by at regional airports, and all levels of government urge communities to maintain at least 3 days' worth of emergency supplies. Urban and rural alike, Oregon's residents are reminded that interconnected systems can unravel in moments. Chapter 13. Ancient tsunamis, ghosts in the forest. Deep in the coastal forests, signs of ancient catastrophe remain. Stumps of long-dead trees, roots preserved by tidal mud, known as ghost forests, mark the rivers and estuaries of the Oregon coast. What do these drowned remnants tell us about seismic risk? Archaeological and geological research links these ghost forests directly to past subduction earthquakes and tsunamis. In 1700, the ground dropped abruptly, allowing seawater to surge inward, drowning forests and reshaping river mouths. Records from indigenous tradition and Japanese history both document the event. Each root system, each sedimentary layer, is a reminder that the worst has happened before. Archaeologists wade into brackish forest to extract tree rings, matching them with the known timeline of disaster. The remains of ancient villages and artifacts, a silent testament to resilience and loss, give human dimension to the risk described by scientists. The landscape itself remembers, holding stories that urge vigilance. Chapter 14. Public Safety, Warnings and Reality. Official warnings come rapidly, sirens tested, evacuation maps handed out, alerts pushed to cell phones. Yet in every disaster, the line between readiness and chaos can be thin. Are Oregon's cities and residents truly prepared for instant catastrophe? Emergency plans exist and drills are common, but the speed of an earthquake, and especially a tsunami, tests even the best prepared community. Drills sometimes reveal gaps, traffic jams at key intersections, incomplete evacuation routes, or residents who dismiss or ignore warnings. The Red Cross and public agencies urge 72 hours of self-sufficiency, but real compliance is uneven, and communities know instinct and circumstance will still play large roles. First responders train for coordinated evacuation, but many challenges, communication breakdowns, physical barriers, weather, remain unresolved. Public awareness is up, but so too are fears of being caught unprepared. The gulf between scientific forecasts and public response is the final ingredient in Oregon's storm of risk. Chapter 15. The final countdown, living on the edge. Sensors beam their warnings, scientists brief officials. Coastal Oregon sits at the edge, not of panic, but of uncertainty and vigilance. Red alerts and heightened warnings are calls to knowledge and readiness, not despair. Tonight, Oregon's coast is both battlefield and bellwether. A place where time, chance, and nature's will converge. Each alert adds a new line to the region's ongoing story, written not by panic or rumor, but by the fundamental movements of the Earth itself. As long as the Pacific shifts and the ground moves, uncertainty is the only constant. On dark roads, neighbors check in on one another. In living rooms, families gather for updates and reassurance. Beneath the veneer of normal life, the ground's unseen power is acknowledged. The Cascadia Subduction Zone's future is not debatable, only unknowable in its timing. Heightened alerts pulse through Oregon, not simply as fear, but as a call to unity and preparedness. The world now watches as Oregon's coastline braces itself, sheltered by knowledge, guided by history, and driven by the strength of community and hope. The test is formidable, but Oregon stands, as ever, a place of endurance, solidarity, and determination, ready for whatever story the Earth writes next.